Welcome back, everybody. We're going to do another round of fireside chats. My name is Jordan Creamer. I am the Hive community manager. Today's fireside chat, we're going to be chatting with Andrew. Andrew is an industrial security expert, author, and podcast co-host. Welcome, Andrew. If you want to give us a little bit more about your background, please start.
Absolutely. Thank you for having me. My background, I've got the gray hair. I've been around for a while. Historically, I did, about 10 years developing industrial control systems. These are the software systems that control some of the world's largest pipelines, largest power grids. This was at Hewlett Packard. Hewlett Packard split. I spun off to Agilent. I wound up leading the project, developing middleware, connecting IT and OT networks, connecting OT systems to SAP. That was the thing to do back in the late 1990s. Connected a lot of networks together, contributed to the cybersecurity problems that now plague many industries. I got religion. I wound up the chief technology officer at Industrial Defender, developing the world's first industrial SIEM. And now I'm at Waterfall. I lead a small team of experts. We work with some of the world's most secure industrial sites. We learn from them. We spread the word. I work with universities. I work with standards bodies. I work with folks like yourselves, trying to make people aware of needs in the space and what's possible in the space.
Wow. So you've got a very in-depth background. As you said, you've been around for a while doing what you do. So I kind of want to center some of the conversation around some of our railway systems, if you don't mind, for the conversation first. A lot of the followers in the community aren't necessarily an OT background. So I wanted you to kind of talk about some railway systems and OT security, some maybe involving a little bit of IT security. Just tell me what it is, what's up with that. Talk to me a little bit about how that works.
Sure. So, where to begin? I'm less familiar with rail systems than I am with some other industries, but I'm coming up to speed because literally about 3-4 years ago, people in the rail industry started tapping us on the shoulder saying, "Come talk to us." We're going,
Right.
Sure. What happened here? The impression that I have looking at this from the outside is that the rail industry for over a century has been focused on safety.
Okay.
You know, bluntly, don't let the trains collide.
Right.
The telegraph was invented in part to communicate the status of trains across continents when you only had one track across most of the continent.
I did not know that. I had no idea. That's wild. Okay. All right.
The sense I get is that the whole industry has been, heads down for a century, safety, 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 and then looked up and went, "Oh, shoot, cybersecurity.
Yes.
We have to do that too, don't we?" And started taking measures. Ever since the computer was invented, give or take a decade, we have been deploying computers to control physical processes in rail systems, in power plants, everywhere. Automation. I mean, what are the top priorities at most industrial sites on the planet, be they rails or power plants or refineries? Top priority is safety. Don't kill anyone. Don't cause an environmental disaster. Second priority tends to be reliability. Keep the billion-dollar investment doing things instead of sitting idle. And the third one is efficiency. The focus on efficiency for automation is why we have cheap drinking water. It's why we can, spend, what is it? In Calgary here, it's $4 to get on the train and travel from one end of the city to the other. Efficiency is one of the big reasons why we deploy automation. And so we've been deploying for 40, 50 years. We've been deploying more and more computers to automate our systems. And this is the big picture I'm talking about here. They do everything from switching the tracks. I'll talk more about positive train control in a moment. Switching the tracks to keeping track on our cell phones of where the locomotives are. Is my train on time? For 50 years, we've been deploying more and more computers. They all run software. All software has bugs or can be misconfigured. For 50 years, we've been deploying more and more targets. And data in motion is the lifeblood of modern automation. Everything is connected. Increasingly, everything's connected directly or indirectly to the internet, to the cloud. And every communication path is an opportunity for a cyber sabotage attack, for attack information to enter our system. The only way a control system can change from a normal state to a compromised state is for attack information to somehow enter the system. For 50 years, we've been deploying more and more connections between our ever increasing number of targets, deploying more and more opportunities to attack that ever increasing number of targets. There's no surprise that we have a problem today. Are any of these trends going to disappear in the next 20 years? I don't think so.
I don't think so. Yeah.
The problem is going to get much worse before it gets better. Specifically, what are we talking about? To me, the some of the worst case stuff happens when you're controlling the trains. The locomotives are moving, and so wireless communications has a huge role to play in the rail system, and that's generally not true in other safety critical systems. Most other safety critical systems try really hard to avoid wireless. They use it when they must. Shipping uses it when they must. If the ship is sinking, you're going to send out a wireless SOS. You have to. You have no choice. It's a safety critical function, but you have to do it. So you do it. With rails, the rolling stock is moving. And, if you want to send an all clear signal for the next section of track, you kind of have to do that wirelessly. Fundamentally, all CPUs are at risk of being compromised. This is the problem. And there are unique challenges in the rail sector. The focus on safety means it's very hard to change anything in the entire sector. I was talking to an expert. You've got some experts from the sector in your community. I was talking to someone more expert than I was, literally just a couple of days ago about this. And he said, Andrew, if you want to patch one of these systems on the rolling stock, you need the regulator's permission to patch the system. How many regulators are there in the world? How many jurisdictions? I didn't ask that question. I'm guessing there's 25, 50, 75. What's the vendor going to do? Go to 75 vendors and sit on the patch until they're approved? Put it out there so that the bad guys can look at the patch and see what's been fixed and have the attack, the opportunity to attack systems that haven't been patched yet because the vendors or the regulators are too slow. These are unique problems. These are problems that almost don't exist in other sectors. And it's because I was going to say it's because of the engineering discipline, but it's not that engineers are doing anything wrong. It's because we must use the engineering discipline in these systems where public safety is at risk. And the buzzword in the engineering field is engineering change control. Every change, a patch, every change is a potential threat to safe operation. Before you install the patch, you have to answer the question, how likely is this patch to kill anyone? And the answer is never, it's perfectly safe. Safety is not a binary value. You're not safe or not. It's a spectrum. You can always be safer. You can always be less safe. Safety engineers know this way better than I do. And so you have to test the patch. You have to study the patch. You have to study the system for some time before you're confident enough. You're never completely confident enough to start rolling out the patch to your least critical systems. And once they're done and seem to be working, there hasn't been a problem, hopefully, rolling out the patch. You then start rolling it out to the redundant part of a redundant pair or triplet of systems. And then you fail over to the redundant part and see if it works. And if it doesn't, you fail right back. It's a long, painful process. And the whole time, the fact that systems are hard to patch does not mean the threat goes away. The threat is still there. We have to deal with it. So, and I wanted to say just a few more things about positive train control. There was an attack reported a few weeks ago now. A wireless signal was sent in, just a series of 3 tones was sent on the right frequency. Emergency stop signal for something like 20 trains. You might ask, can't we encrypt things? Can't we? And the answer is yes, we can. But everything we do like that also adds complexity. Most security adds complexity. So there's more to it. I could go on describing the problem, but we don't want to spend the whole, one other bullet, if we're talking passenger trains, a lot of the time, especially in metros, metro cars are designed to detach. You don't have a locomotive and 6 cars behind it or 60 cars behind it. Every segment or pair of segments can act as a self-propelled locomotive, which means all of the automation for the metro needs on the rolling stock has to be in pretty much every car, because every car can be the locomotive. That's a lot of automation to squeeze into a tiny space that people are walking by, knocking on the door all day long. I've heard horror stories of not metros, but passenger trains, people going into the washrooms, at least pen testers. I don't think it's happened in the wild yet. Pen testers going to the washrooms, taking the mirror off the wall where the wiring is exposed for the rail networks, plugging a Raspberry Pi or some other nasty with a wireless controller into there, putting it back and saying, now I can do what I wish here. There are unique problems in the space. There are people working on them. This is good, but it's a challenging environment.
Absolutely. It's really interesting. I just keep, kind of nodding and listening along to everything you're saying. It's funny because you talk about certain things and you're talking about them from a unique perspective that I don't think about when I'm using a passenger train or a metro or a rail car for anything, or when I have to stop because a 15 car length train is carrying coal, for instance, because it's a bigger thing in South Carolina where they will carry several cars worth of coal around on the train tracks. And now I'm just thinking I'm late for work. I'm not thinking about all the other things that are going into that while I'm late for work. I'm just thinking about how I'm going to be inconvenienced. In one of our previous communications that we've had via email, you started off by mentioning some of the failures in imagination based off of 9/11. I'd really like for you to kind of dig into that just a little bit for us, considering, during the filming of this video right here, we're only a couple of days after the anniversary of 9/11 itself. So do you mind elaborating?
Before the turn of the century, late 1990s, who was doing OT security? Who was doing industrial control system security? There was maybe, I'm not even sure there was a dozen. There was maybe a dozen academics at universities studying the problem, writing about it, saying, we should really do something about this. PhDs. After 9/11, 9/11 was a physical assault. It was not a cyber attack. Do not get me wrong. Lots of authorities around the world said that was unexpected. We never imagined that someone would use an aircraft as a weapon. This is unacceptable. So they're taking measures to address that. And they said, by the way, where else have we suffered this failure of imagination? What else have we missed? And they looked around, and one of the fields they settled on was critical infrastructure cybersecurity. We're just not looking at this. Someone has to do this. And so in the years that followed, and it was about 2 years before serious funding hit the field, government departments were created, people parachuted into it. We had a major investment in the space, in starting to explore the space and understand the problems and develop solutions. And in the first generation of advice that came out, and the very first standard that I recall coming out was API 1164 in petroleum industry. American Petroleum Institute came out in, I think, 2006. So 3 years after the big push. It takes time to put out standards. The first volume of what's now IEC 62443, the most widely cited, most detailed industrial cybersecurity standard in the world, came out in 2007. That first generation of standards and guidance, there was other documents coming out of governments. Who was writing them? Well, the engineering community responsible for the automation systems generally wasn't trained on cybersecurity. It wasn't something they were thinking about. So they recruited IT experts on cybersecurity. The IT experts came in. And so what you wound up with was sort of an IT flavor of cybersecurity advice. What does that mean? Well, the first documents pretty much universally said, your goal as OT, but the term OT hadn't even been invented yet. Your goal as industrial cybersecurity experts is to protect the information, protect the confidentiality, integrity, availability of the information, the CIA. But they said, we recognize that industrial systems are a little different. Safety is important. Reliability, keeping the lights on is really important. So maybe the priorities are different. Protect the integrity, then the availability, protect the availability, then the integrity, then the confidentiality, mix it up like this. But the bottom line was, great. The priorities are different. Patching is hard. We get that. Antivirus is hard. I mean, what if the antivirus, a bogus, not bogus, a busted antivirus signature comes through and quarantines half the control system and shuts out the lights? We recognize patching is hard. Antivirus, even passwords are hard. You know, it's just really hard to put passwords in some circumstances. But they said, as much as you can, do it the IT way, because that's the right way. I know it's hard. Try harder. Invent a way to do this. And don't get me wrong, I'm grateful to that first generation of advice. It bootstrapped the whole industry. But since then, we've realized that it's subtly wrong. And the sort of second generation of advice is phrasing things differently. And we're actually coming into the third gen here, so I'll talk about that. But the second gen said, look, the number one priority in a rail system is safety. Do not collide high-speed trains and cause a mass casualty event. Okay. Do not overturn trains carrying oil in the middle of a population center. Safety is number one. Your second priority for almost all industrial operations is reliability. Most of these operations are massive investments. Keep the massive investment producing something. And, often the output of these large systems is essential to national security. Keep the lights on, keep drinking water in the taps, keep gasoline in the gas stations. And the third priority in most physical operations is efficiency. Do it efficiently so that we can afford to use the results, not protect the information. In fact, the second generation looked at it and said, look, all cyber sabotage on IT, what are we trying to do? Most of the time, not all the time, but much of the time, the priority is prevent espionage, prevent theft of information. On OT networks, the priority is prevent sabotage. So prevent attack information from entering the system. And so in the second gen, they started saying, controlling the flow of information is very important. We need protection. We don't need to protect the information. An attack can come inside an encrypted connection just as easily as it comes inside a plain text connection. We don't need to encrypt the connection. What we need to do is protect operations from incoming information, control the flow of information to make attacks as difficult as possible. And the third gen, I'll talk about in a bit, but we've been talking about it. It's sort of looking at the other side of the coin, looking at the engineering side in addition to the cybersecurity side.
It's so insane to me, I think, that we even had to get to a point where we had to start thinking about our infrastructure being a projectile used against us in some form or fashion or another. And I do have a really heavy agreement on the fact that it makes sense to protect basically the control of the data, not the data itself, but the control of the data into the system and how that works and how that information flows. That makes a lot of sense to me. Even as like a primarily IT, less OT side of the house kind of person, like that makes sense to me. I can get behind that because then it also continues to move forward with safety of the information, safety of the event, the critical infrastructure actually operating, the availability of me to be able to go and fill up my car, right? And then, of course, keeping the cost as minimal as possible, oil and crude expenses, not, politically obtained in that. But as far as the actual availability of it based off of how the OT works, then we're still able to get it at a relatively less expensive price than some other places would be able to. And that seems to make sense to me. These are my top 3 priorities. How do I keep it safe from there? And I think that generation did a really good job. What's the latest and greatest for things like threat reports, for what you guys deal with on a daily basis? So a lot of our community reads threat reports all day, every day. I myself have read like 10 threat reports today that have come out recently on certain things. I've got all these RSS feeds and flashes and news alerts, and it's all really great. But what's the difference here for you, and what are you guys dealing with on your side of the house?
All of that is useful. Okay. If your job is detecting intrusions, you need actionable intel. You need
Absolutely.
to know what's happening in the world. This is the nature of the beast. What I when I hear the question, I'm thinking waterfall. We take a different approach to it. We're looking at macro environment rather than, this attack, this attacker, this intel. What we observed is that the threat environment underwent a state change. It changed fundamentally from last decade to this decade. And this is on the OT side. The report that we've been doing for years, and bluntly, we're shocked to see a couple of years ago, oh no, something's changed, and tried to tell the world about. The report we've done is one where we count, we do the numbers, big picture, and we count deliberate attacks, not errors and omissions, not somebody fumble fingered something on a computer controlling the rails and a track switched the wrong way. Deliberate attacks that caused physical consequences, not attacks that were defeated, not attacks that stole information, deliberate attacks that caused physical consequences in the industries we track, which is heavy industry and manufacturing, everything from toasters to automobiles and aircraft parts. Deliberate attacks caused physical consequences in the industries we track in the public record. Okay, no private disclosures. Everything is verifiable. So in that set of attacks, what happened in 2010? How many attacks were there like this in 2010? There was one. It was Stuxnet. You might have heard of it. The attack, the very sophisticated attack that is accused of having destroyed 1,000 uranium gas centrifuges. How many attacks were there like that in 2011? There was zero. There was lots of attacks, a lot of them on the power infrastructure in Western nations, but most of those attacks were stealing information, presumably to use in future attacks that caused outages. But you can't really figure out what the intent of a lot of these attackers are. So a lot of them were stealing information. Some of them looked like they might have been trying to impair operations, and they were defeated before the lights went out. So 1, 0. How many in 2012? There was 2. 2013, there was 0. 2014, there was 1. 2015, there was 1. 2016, there was 1. For the whole decade, we're looking at bouncing around between 1 and 5. That's it. For the whole decade, the threat to physical operations seemed theoretical. Governments were worried. Forward-looking industry was worried. Man on the street said, where's the beef? Where's the outages? And, as we were doing the research, we saw that, now, if I get the numbers right, I think it was 2019, one of those years, there was, I think it was 18 attacks with
That's
physical.
a big jump.
Big jump. The year after there was, I think, 23. Year after that, if I remember correctly, was 57. For 4 years now. These are small numbers. These are very few data points. It looks like we've shifted into a mode where we're growing exponentially. You do the exponential backtracking, and it looks like it's increasing about 2.4, 2.45x per year, if you believe the numbers. What does that mean? That means a 10x increase every 2.5 years. It means a 100x increase in 5 years. If this trend continues, and we don't know if it's going to, if it continues, we're going to see between 4,000 and 5,000 attacks in the year 2027, impairing over 10,000 physical sites. We're at 57. Most of it's ransomware, but hacktivists are increasing faster than ransomware, but they're still a minority. Does anyone believe we're at 57, and this year we're looking at, we don't have all the numbers yet, the year isn't over yet, but we're looking at, pushing 100. Does anyone believe we're ever going to go back to 2018, where we had one attack, a semiconductor fab in Taiwan, that had physical consequences? I don't think so. I think we've gone from a state where the threat is theoretical to one where it's very real and more than doubling annually. I would paraphrase this in a rail analogy. This is a crisis coming. This is a crisis coming down the tracks. It's a really big one. If we believe these numbers, if this trend continues, we're in trouble. To me, I don't think it's going to be possible to build a wall big enough to stop that train. I think we have to get off the tracks.
When you talk about the increase of these attacks, are all of those something that could maybe, or when we talk, because we mentioned mostly ransomware, but an uptick also in hacktivist groups, are those including things that are just stealing data, or all of those, are any of those also including physical attacks that maybe have, like, and we'll just mention for a moment the Colonial Pipeline, like it did technically affect some things, but we were still able to maneuver around it and get the oil and gas out the way it needed to go. Are those attacks, in your eyes, seeing physical effects to the ecosystem of critical infrastructure itself?
All the attacks we count have physical effects.
Have physical effects. Okay, that's interesting to hear the numbers and how they increased over time. I wonder if that goes back to the statement you made earlier about how we increase putting things on the network and having more computers and having more places where a attack can be inserted into the network?
This is speculation. I look at the
Sure.
numbers. You look at the numbers. My own speculation is that what we're seeing is it's twofold. One is a change in motive, and a second one is a change in TTPs. What is that? Tools, techniques, and procedures.
Tactics, techniques, and procedures. Yeah.
Thank you. Tactics.
Yeah, no problem.
I mean, motive is ransomware.
Absolutely. Yep.
Scourge has figured out literally how to make billions of dollars. It's an industry now. There's a whole support infrastructure for it. You know this better than I do.
Yep.
And a lot of what we're seeing in the OT space is collateral damage. Colonial crippled the IT network. The CEO of Colonial went in front of I think it was congressional committee, swore under oath. Here's what happened. IT was compromised. The IT group picked up the phone and called the pipeline operator and said, "We have a problem. Defend yourself." Click. And the pipeline operator looked around, looked at procedure, and said, within 15 minutes of the phone call, made the call. According to procedure, if we can't trust the IT network and we're connected to the IT network, we must shut down the pipeline. And he shut it down. This is what operators do. They follow procedure. If there's a disaster and the operator failed to follow procedure, it's on the operator's head. If there's a disaster and the operator followed procedure, it's on the engineer's head. The engineer designed the procedure. So the operator followed procedure, shut the pipeline down. They inspected the pipeline. There was no evidence of compromise of the pipeline, but they were not willing to start it up again until the all clear came because of the risk of propagation. So this was, the buzzword is abundance of caution. Another thing that we're seeing is in many industries, especially transportation. I mean, the classic was Maersk, not rails, but shipping. The IT network was crippled by NotPetya, which was not even ransomware. It was nation state attack pretending to be ransomware. Crippled the IT network and crippled the system that tracked the EDI files that kept track for each container in the system, millions of containers, where it was going. The OT systems were unaffected. The ships navigated safely to port. The OT systems on the ports were unaffected. The cranes could lift the containers off the ships, 8,000 containers on their ship, and put it on the waiting semi-trailers. But they could not print the instructions to the driver saying where to take the container. Everything stopped. So this is an example of a dependency. If you cripple IT systems that are essential to OT, well, now you've crippled OT because OT depends on these systems. So some of this is collateral damage. Some of it's deliberate. All the hacktivist stuff is deliberate. Even some of the ransomware stuff is deliberate. The Snake ransomware has code in it to identify when it's running on an industrial control system, deliberately shut down the servers so that, presumably, I don't know their motive, so that it's easier to encrypt the real-time databases and the config files so you can't start the servers up again. This is my guess. So we're seeing across the board, but part of it's ransomware, part of it's hacktivists. The hacktivist threat is growing. All of the hacktivist attacks we've observed, and there's not that many of them, but all of them were associated with two physical conflicts. The ongoing physical conflict between Iran and Israel, and the new physical conflict between the Ukraine and Russia. Right. All of the hacktivist attacks that had physical consequences were part of that. So yes, motives are changing. Another thing that's changing is capabilities. In our research, and we're not malware disassemblers, but in our research, we observe ransomware criminal groups over and over again adopting TTPs from nation states. What nation states used to do to each other exclusively 5 years ago, ransomware today is doing to everybody with money. This is distressing because a lot of us said, well, we're just a small metro. Why would a nation state come after us? We're not important enough for a nation state to invest in attacking us. Yet the problem is that the ransomware groups increasingly are using nation state TTPs, and they're coming after us because we have money. So the world has changed.
One of the things that I can't emphasize enough from what you're saying, and I mean, just hearing you also say it confirms it again for me, is as a cyber threat intelligence analyst myself, primarily one of my things used to be being able to understand exactly the target, motives, operations, and anything behind the types of adversaries. It's grown increasingly harder for us to understand an adversary or a ransomware group's motives and targets and operations because they now so often will overlap, as you mentioned, a nation state or a hacktivist group, or even something that's already happened that looks like an insider threat kind of thing, when it really was just, a third-party vendor already had this on their system. Now we're all infected kind of thing. It's now it's all downhill. We just have to clean up an incident response style this guy. It's so refreshing to kind of hear it again from another place, another time, another sector of ITOT, kind of always in this. It's seemingly like a war. It feels that way sometimes because people want to talk about, well, IT versus OT, and I'm like, no. It's both together. We kind of need to treat them like they are, as the dependencies that they are, as you mentioned previously. And I think that's one of the things that kind of more people need to bring together. It's not a fight against each other. We really are working more together than ever. And I hope that continues to remain true so that we continue to have the lights on every day. We kind of talked about some of the bad news just now. The threat to the infrastructure sector has grown increasingly. Some of the things that we've seen are TTP changes and how it's harder to detect, as we just talked about, what type of actor you're looking at, or what is really happening between the connection of the IT/OT dependency kind of systems. What are we going to do about this, or what are we already doing about this moving forward?
Well, we have advice out there now that is not as confusing as it was to the people who live and breathe in the space, because it's talking their language, it's talking safety, it's talking reliability. But the brand new thing that I'm excited about, and I don't use that word often, but I am excited about this, is sort of engineering coming into its own as a partner in the space. Historically, it's been, we don't understand cybersecurity. Can you tell us what to do? Do it the IT way. That doesn't make any sense. Try harder. And there was this conflict. What we're seeing now is an initiative. We're actually seeing it in many places, but the sort of the clearest example of it was last year's Department of Energy in the United States funded Idaho National Labs to produce a cyber-informed engineering strategy, not cybersecurity, an engineering strategy, and published it in about a year ago. There's a very active community. And it's a strategy, it's a plan. Think of it as a roadmap. It's not a recipe how to do cyber-informed engineering. It's a roadmap saying, we need a recipe. Somebody should develop that. So there's a large community contributing to the development of this space. But the good news is that a lot of the tools and techniques are very old. It's a question of assembling them and making people aware of them and setting up a system to use these tools systematically. So what am I talking about? I'm going to come back to the rail industry in a moment, but let me give you sort of the easy example. The example that I use is in power gen. Think old school. Think a coal-fired power plant. Imagine that you are the technician responsible for a 4-story boiler. Okay, what is a coal-fired power plant? There's a furnace on the first story. There's 3 stories of boiler above the 1 story of furnace. Coal dust is blown into the furnace. It ignites instantly. It's consumed in less than a second. It's turned to heat and, of course, carbon dioxide and water. Heats the water in the boiler, produces steam. The steam goes into a turbine, turns the turbine. The turbine has an axle to a generator, turns the generator, produces power. This is a generating unit. A large power plant will have 4 or 6 or 12 of these generating units. You're the technician whose job it is to keep these boilers in prime condition, to keep them, the instrumentation calibrated, to replace instruments that have failed. You've got the gamma ray testers to test for corrosion on the inside of these boilers. These boilers are your baby. You work all day long inside of the kill radius of a worst case boiler explosion. If one of these boilers blows up, you never see your kids again. How would you like to be protected from the threat of a cyber attack coming in and overheating the furnace and overpressurizing the boiler? Would you prefer a buckle valve, which is, a hole in the boiler, a steel plate jammed against it, a pin holding the plate in place, and if the pressure in the boiler becomes too great, it forces the steel plate against the pin breaks, the steam escapes, and there's no explosion? Would you prefer a buckle valve or 3, because these things do wear out, or would you rather have a longer password on the computer controlling the furnace?
I'm gonna take the buckle.
Most of us would. The second most popular answer I get is, I want both. Thank you. This is my life. Give me both of them.
That makes sense to me. I think that for most people, they would go with the buckle valve, the release, right? So, because that does it automatically. I don't have to run to the computer, put in that really long password, and then do something manually myself. That automatically ensures that I get to walk out of here today and go see my kids again, right? That's the thing.
Precisely. So here's the thing. Where's the buckle valve in the NIST cybersecurity framework?
Yeah, I've never, yeah.
Where's the buckle valve in IEC 62443, the world's most detailed, most widely used industrial cybersecurity standard? Industrial.
I'm going to take a guess and say it's not there. Yeah.
The rail industry is using 62443. The latest I saw was the very latest new standard in the space is out of Senelec in Europe. Technical specification TS 50701. The subtitle is Adapting 62443 to the Rail Industry. That's what it does. Doesn't say a word about this kind of engineering mitigation for cyber threat. Here's the thing. The engineering community has powerful tools that have been developed in safety engineering, in protection engineering for decades, powerful tools to address physical risk, to address the risk of a bridge that a train is moving over collapsing in an earthquake, to address the risk of a hurricane coming through and turning the lights off. All of these physical threats have the engineering community has designed measures to address them to the extent that it makes sense. Nothing is ever perfect. We can't afford perfection. It would, increase the cost of our electric power tenfold. You can't do that. Occasionally, I see the engineering community using these powerful tools to address cyber risk, but they're not doing it systematically. They're not doing it across all industries. And this is what CIE is doing, saying, look, these tools exist. They're powerful tools for addressing cyber risk. They have nothing to do with cybersecurity. They're engineering, not cybersecurity. So we need, the point of CIE is to gather these techniques into a body of knowledge and train engineers on cybersecurity so that they know where and when and how intensely to apply these solutions. And B, develop the body of knowledge, train the IT people that there are these tools available and that folks, you have to talk to each other. And there's, of course, much more than that. I've got a new book coming up. One of the focuses of the new book is answering the question, how much is enough? How can you tell how much of this protection you need? And so, what we're seeing is, in a sense, a lot of stuff coalescing into a newish field called network engineering. And network engineering is focused, not on mechanical safeties. Network engineering is focused on basically keeping the lights on, keeping the train moving. If you've got a mechanical safety that engages, what happens? You return to a safe state by 9 times out of 10 shutting down. That's how you return to a safe state. Well, that's great. Nobody's died, but the train isn't moving. The whole system isn't moving. This is national security at stake. This is critical infrastructure. If you've got to move your military from one end of the nation to the other, you can't afford to shut the whole system down. So if you want to prevent unacceptable reliability outcomes, one of the tools you have is network engineering to prevent attacks entering the system in the first place.
That's really wild that you talked about engineers learning about cybersecurity, and then also cybersecurity folks learning about what the engineers do. It's really strange, the similarities I'm seeing in this conversation and the way that the group is coming about to come together to make a better environment for everyone is a very similar argument and working group is what I'll say for the operations as a whole to kind of join with intelligence to bring intelligence into cybersecurity. For years, the intelligence analysts at cyber exercises were getting coffee and sitting in like broom closets and not doing anything. They weren't participating in the intelligence portion of cybersecurity because they were like, no, operators know what they're doing. They'll figure figure it out. Like, that's cool that operators know what they're doing, but do they understand the theory of the threat and how the threat operates traditionally? Now, of course, we've talked about how that's grown increasingly harder, but that's why we have CTI experts and things of that nature, folks that have really dug down into understanding that. And I like how you also touched on engineers learn a little bit here and security guys learn a little bit here. We don't ever want to cross them over too far, because then they become too much one-sided or the other. We want you to just know your job and understand the other. And that's really a good, it's really a good crosswalk for them to understand and cross-reference, cross-train. I really love that comparison. Another thing you mentioned here just briefly for a moment was if you got to move your military from one side of the country to the other, a lot of folks don't actually know that most of the time when we need to transport something, tanks, heavy machinery, equipment, missile systems, those don't go in like the back of a C-17 or C-131 or something like that. They go on a railway on a big flat track, and they get their transport across the U.S. literally in some cases, or from one post to another. And that's why some of our train depots and things like that are really close to military installations, because we have to ship those things. Texas is a really good example of that out there, Fort Bliss with some of those guys. I don't think a lot of people realize that you're not getting this item anywhere without a rail. You talked about that buckle valve that you mentioned, and I really am kind of interested. We've been talking about how that option to have that, or the password, that conversation is new. But we mentioned that some of the tools and techniques that we could be using are not new. They're old things we could be using. So can you elaborate just a little bit more on that before we move on to our next topic?
The good news is that a lot of the stuff is very old and well understood, and its application to cybersecurity has even been documented, some of it. So my first introduction to this came from the ISA's textbook, Security PHA Review. PHA is Process Hazard Analysis. This is some people call it a HAZOP. It's a kind of audit that is required by OSHA, the Occupational Health and Safety Administration, and by many other jurisdictions around the world. This kind of audit that basically assesses threats to public safety, threats to worker safety. And, the engineers use it as a tool to figure out, have we done enough? Do we need more? And so, Security PHA Review, like I said, book that came out in 2019. It's available on the ISA bookstore. I think it's available on Amazon as well. It says, take the output of your PHA analysis. It's a spreadsheet typically. There's a set of rows for each consequence you're trying to avoid, the boiler blowing up. There is a set of, the next column over is all of the causes that might cause the boiler to blow up. You might have a blocked exit valve from the boiler. You might have overheated the furnace. I don't know. I'm not a boiler expert. There's probably 2 or 3 other things that that cause the boiler to overpressurize. There's another column that has all the mitigations in place. The overpressure valves. If the boiler pressure gets too high, an alarm comes up on the operator HMI, the human machine interface for the plant operator. They see the alarm and they say, "Oh, that's not right," and they shut down the furnace. They give a command to shut down the furnace so that we can figure out what's going on here. And then there's other columns. Those are the main ones that SPR focuses on. And they basically say, okay, for each consequence, look at all of the causes. Are any of the causes hackable? Well, yes, someone could get in and send a command to close the outlet valve. Someone can get in and send a command to overheat the furnace. Okay, so if any of the causes are hackable, then are all of the mitigations hackable? Well, the alarm going to the operator is hackable. You could cripple the alarm server so it never sends any more alarms. You could reprogram the device that's measuring the pressure and say, always report normal. But the overpressure valve is not hackable. So they said, if you have any cause that can be hacked and all of your mitigations are hackable, now you've got a problem. You've either got to, and they recommend, you've either got to put an analog mitigation in there so that it's not hackable anymore, or you've got to do some really serious cybersecurity. And this is going to be expensive. So most people say, let's buy a valve and stick it in. So this is the methodology. It doesn't sound like much, but I kid you not, before I read this book, I had no idea that this was possible. And after I read it, I went, That's blindingly obvious. Of course, we should have been doing this for the last years. It's the best kind of book. I'm an author. I aspire to writing that kind of book where before you read the book, you have no idea how to do something. And afterwards you go, it's so obvious that you have to do it this way. That to me, it's a brilliant book. But that's one example. Another one is Countering Cyber Sabotage is the official title, but the subtitle is what everybody knows it by. Consequence-Driven Cyber-Informed Engineering, CC, from Idaho National Labs. It's mostly a book about risk assessments, but it's got 3 or 4 chapters on mitigations in there. The example they give frequently, and they talk about unhackable mitigations. The example they give frequently that I think is widely applicable is manual operations. It's not universally applicable, but the classic example is water systems. Water treatment systems tend to be physically slow processes. Things change over a course of minutes. This is a human time scale. In an emergency, if you still have manual valves that you can use, if you've designed the system correctly, in an emergency, you can turn off all of the computers in the automation system, say, IT, clean this mess up, and operate the system manually and keep drinking water in the taps, or keep the sewage from raw sewage from flowing into the river. So it talks about unhackable mitigations. And my own book talks about network engineering, the secure operations technology, and I'm elaborating on that in the new book.
I really did, before we kind of concluded out chatting today, I really did want to hear about the previous book and then the upcoming book as well. So I wanted you to kind of talk to us a little bit more about those. Potentially, there's a large potential for the community that may want to go in and see the books, read on those, and then also read on the ones you've mentioned already that you've read to help you get where you are. So if you don't mind elaborating on your books, I'd love to hear about those.
Absolutely. So I'm working on my 3rd book. Let me step back and give you some of the history. My first book, SCADA Security: What's Broken and How to Fix It, came out in 2016. It was read. It's called, I know it as a red book. It received mixed reviews. I got feedback that ranged from, Andrew, I disagree with your premise so fundamentally that I could not finish reading the book.
Oh, it's direct.
All the way to, and this is from an internationally recognized expert, all the way to, another internationally recognized expert saying, Andrew, it must have taken weeks of your life to write this book. Yet everything you've written is obvious. What would possess you to spend so much effort documenting the self-evident? So everything.
Yeah, but I feel like if you wrote something that was self-evident, then few people are probably still not doing it right. There's got to be a reason it was.
There's the feedback ranged from disagree fundamentally to so obviously true it's not worth writing down. I learned 2 things. One is that experts disagree. Okay, it's not just a question of practice. Experts have different perspectives. And the second is nobody likes a critic. The subtitle says it all. What's broken? I criticized a certain widely used approach to cybersecurity and industrial systems. And I was thinking I would show people the light and I would lead them to the light. No, you criticize people, they get their shovels out and they start digging deeper into their positions. So that was
everything the light touches.
Yeah, I regard that as a failure. So the second book, Secure Operations Technology, I went to the other extreme. I said, the world's most secure industrial sites, they ask different questions. They get different answers. They look at the problem a different way. Would you like to know what they do? What they do differently? I don't, they do a lot of the same stuff. What they do differently, first they do this, then they do that, then they do the other thing. If you see value in any of these, cherry pick them and use them. And the feedback I got was, that's great. I wish you'd introduce things better because I couldn't follow half the book because I did the deep dive and I didn't come up for air for 12 chapters. But the other question I got was, Andrew, it's great that these techniques exist. When should I use them? Do they, I've got a small shoe factory. Do I need to use these techniques? And this is sort of what motivated the 3rd book, which is looking at the big picture, saying, well, how much is enough? When do you need engineering grade techniques? When, should you use IT techniques? And it turns out it's not an either or, it's an and. I work with the world's most secure sites. The sites that I've seen using engineering grade protection the most intensely are also, they're the very same sites that are using IT grade protection the most intensely. They're not choosing between them. They're using both. And this is because, we're talking nuclear generators and, high speed passenger rail systems. This is, they're the ones that are doing both.
Mm-hmm.
But to your point about the black book, the blurb on the back says it all. Engineers tend to ask different questions. They don't ask, how do I protect the information? They ask, how can I get protection from information? And the methodology I document in here, saying, here's what they do. They first, draw a line around the critical system, whatever it is, imaginary boundary. Often it's a cyber boundary. It's the firewall boundary. And do a survey of all of the ways that information can get into the system. A complete inventory of all of the ways that information can get in is also a complete inventory of attack vectors. The good news is that there tend to be less than 24 of these at any site, no matter how big. How can information move? Well, it can move through the firewall. It can come in, on a USB. It can come in on a floppy. It can come in my head with a password and malicious intent, and I walk it into the site and I express that attack through my fingers, that attack information. So they produce a comprehensive inventory of attack vectors, and then they put as much as possible physical mitigations in place to address those attack vectors. So, on the offline side, if you don't need a DVD drive in a computer in the automation system for the rail operations center, remove it. It's not there anymore. It's no longer a threat vector. USBs, put technology in place that forbids, that just blocks USBs being mounted. When you need one to come in, it's got to come in through a scanning kiosk. The files get scanned with 8 or 12 antivirus vendors. It gets written to a write once CD. It gets carried across the physical security boundary to a computer that's on the automation network. Now you can take the files off the write once CD, put them on a file server. You're not carrying USBs around. So, physical mitigations are chapter 4. None of them are terribly surprising. Most IT people go, I've heard of all these. You're using them more intensely than I'm used to, but I've heard of these. The surprise comes in chapter 5, where I point out that critical systems and increasingly rail systems do not use firewalls between safety critical networks and the internet or the IT networks. They use unidirectional gateways. And, one of the reasons I know so much about unidirectional gateways is this was what Waterfall does. This is what I do all day long. I do unidirectional gateways, but I've got, the learning curve for unidirectional gateways is, how can that possibly work? One-way firewalls won't work. TCP. And so chapter 5 deals with that. Send TCP through a gateway. You make copies of servers. It's physically able to send information in only one direction. It's engineering grade unidirectionality. And you're making copies of servers. If all of your data that you want to share is on an OPC server, copy that out to the IT network. And now nobody needs to ask operations anymore. They can ask the copy. So that hurdle is easy to get over. Chapter 6 is sort of addressing the second hurdle in the learning curve, which is, that's great that, that unidirectional weird stuff can work. Too bad it won't work for me, because I need remote access. I need the vendors to get in. I need antivirus updates. So, chapter 6 deals with those business needs and surprising network design. In hindsight, a lot of the book is about network engineering. And I've got, in the draft of the new book, which goes to print in about 10 days, I've got a whole chapter on network engineering and sort of the bigger picture of, trying to address the question, when do you use this? And it's all about criticality. It's all about what are your worst case consequences? Are they acceptable? If they're acceptable, use IT stuff. And, as much engineering stuff as makes sense, return on investment wise. And I can go into more detail in maybe future episodes. But if it's unacceptable, we need something stronger. We need engineering grade mitigations, either to prevent the consequence, and to prevent the attack getting in there in the first place and shutting us down. Right. And so I talk about not just unidirectional, but the whole space of network engineering. There's a number of ways to control the flow of information, and this is what I dwelled on in the Black Book: controlling the flow of information in not all of the ways possible, but I've expanded on that space of techniques in the new Gold Book.
Awesome, Andrew, that's amazing.
if I might, you don't have to buy these things on Amazon. You can if you want. Waterfall gives them away as a public service.
Oh wow!
The new book launches November 1st. If you want a copy of the new book, and if you're interested in the Black Book, Appendix B of the new book copies, chapters 3 through 6, the meat of the methodology. So you don't need to buy both of them. And as part of the promotion for the new book launching November 1st, Waterfall will be giving away copies to practitioners like yourself. If you'd like to request one, you go to waterfall-security.com/ and then the name of the book, engineering-grade-OT-security, and you can request a copy, and you'll get it probably end of November-ish.
That's amazing.
They're physically shipped, so.
Okay, no, that's awesome, Andrew. I really appreciate that, because that's a couple of things I know a lot of cybersecurity folks like myself usually complain about: the expense of all the books and the certificates and the certificate producing courses or certifications that we take. They're always so expensive. So it's very neat that that's a service that's being done. I'm sure it's going to be really widely appreciated throughout the community. I'm probably going to sign up for a book myself, because it's just now I want to know more. I've talked to you all of twice now, and I want to know more, and I want to ingest more information from you. So thank you so much for all of that, and I really thank you for being here today. We will definitely have more sessions as long as you're available to talk, I'm sure, to the community. I am so intrigued in everything that comes out of your head, your mouth, the books. It's amazing. I love that. So I can't wait to expose the rest of the community to more of what you have to say and educate us on. We are going to call time for today, but I really appreciate you. Any parting words for us, Andrew?
No, just music to my ears. Thank you very much, and I hope there's value. I'm not the only expert in the field, but I am one of the what's the right word? Chattiest. I don't know.
Love that. No, the more we can have information or explain different ways, it's fantastic. I love to hear from you. So thank you again, Andrew, and we'll see you next time.
Take care. Thank you very much.